Complex fractions do not necessarily mean difficult fractions. Instead, they mean fractions in which there is more than one division bar. I'm going to refer to this darker division bar as our main division bar, and we can see above it we have a fraction and below it we have a fraction. And we know that whenever we divide fractions, we're supposed to multiply by the reciprocal of the second fraction. So this problem turns into 2x minus 10 over 4 times 3x over x squared minus 5x. Now we just have a multiplication problem, and we can factor both the numerator and the denominator. In the numerator we can take out a 2, and down in the bottom right we can factor out an x times the x minus 5. Now we can cancel, and in the top left and in the bottom right there is an x minus 5 which can be divided out. Likewise, above and below each other in the second fraction, the x's will cancel. Finally, in the first fraction, the 2/4 will reduce to 1/2. Now be careful to look for everything that is actually still there, and it appears to me that our answer is 3/2. Okay, now that's when you have a fraction divided by a fraction. In this second problem, which I'm going to leave towards the bottom of the screen, I'm going to do this in two ways. The first way, again, is to view this as fraction divided by fraction, but to say upstairs in the numerator we have an addition problem. And in order to add, we need to rewrite each of these over a common denominator. So I would rewrite each of these over x, and the second fraction is already over x. The first fraction was a 2 over 1. So down below in the denominator we multiplied through by x. So up above we're going to multiply through by x and have 2x. And we can combine together and get 2x plus 1 all over x. Now that's up above. Now down below we have another addition problem. This is 4 over 1 plus 1 over x, and each of these can be written over x, and the second one is already over x. In the first fraction, to go from 1 to x down below, we multiplied by x, so up above 4 times x makes 4x, and adding across now we're going to get 4x plus 1 over this x. And then we had what we had in the previous problem, where we have a fraction divided by a fraction. So this bottom fraction will multiply upwards here. We're going to have x over 4x plus 1. And on the diagonal, the x's will cancel each other out, and you are left with an answer of 2x plus 1 over 4x plus 1. Now that way is consistent with what we've been doing already, but I want to show you another way to do this problem, and I think you'll agree it's a little bit easier. Looking at our original problem, notice how there are what I call 4 mini denominators, 1x, 1, and x. Each of those go into x as the least common multiple. So I'm going to multiply the numerator by x, and I multiply the denominator by x. Technically what I'm doing here is I'm multiplying this original problem by x over x, and anything over itself is equal to 1, and by multiplying through by 1 I'm not changing the value of the original problem when I move to my answer. So I'm now going to rewrite that as x over 1 and x over 1, and I'm going to distribute those to both the numerator and the main denominator down there. When you do so, the first distribution, you basically just have 2 times x, which is 2x. Then in the second distribution, the x's cancel, just leaving plus 1. Down below, you have x distributing to the 4, making 4x. And then in the second distribution, the x's just cancel, and you have plus 1. Notice how we went straight to our answer in one step. These two match, but the first time we had quite a few more steps. So I'm going to continue to use this process for the remainder of the problems that we're going to be working on.